Thank you so much. Good afternoon from snowy Bavaria. Thank you so much. First, can you hear me well? I haven't tested the microphone yet. Wonderful. Let me quickly share my screen. There we go. Wonderful. Thank you so much for letting me present our work on the music search application, Musicon Score Search. Now, unlike most of the contributions we've heard so far, we are not actively developing, but rather focusing on using an OMR technology that I'm sure many of you are familiar with. I'm talking, of course, of the MuRET application, which we aim to incorporate into the existing framework of our music search application. So what is Musicon Score Search? It is part of the services offered by the specialized information service Musicology, and it is hosted at the Bavarian State Library. At present, it offers its users an interface to search through a collection of almost 160,000 scanned musical sources from the 18th and 19th centuries. To achieve this, we have so far relied on OMR performed by the SmartScore application and a search mask that relies on n-gram matching based purely on musical pitch. Our goals for the current phase of the project, which started earlier this year and extends until 2026, is to expand the searchable repertoire to include more than 1,800 sources from the 16th and 17th centuries held at the Bavarian State Library. These sources include both printed part books and handwritten choir books. In order to achieve this, we are collaborating with Professor David Riso Valero and his team at the University of Alicante, many of whom are present, I notice, to extend the OMR software MuRET to train a model for analyzing our sources and to create an offline pipeline to batch process them and integrate them into our existing index. Our roadmap encompasses the training of the model, which includes the definition and implementation of add-ons for MuRET based on issues we encounter. That's where we are right now, followed by the automatic transcription of the entire corpus to MEI and its integration into our existing search index. To give you more insight into how we structure our work, I will quickly describe the OMR workflow we are using before showing you how we process the training material before batch processing our entire corpus. Finally, I will touch on some issues we have encountered. So OMR with MuRET is divided into 3 distinct tasks, and we have talked about all of these in the course of the workshop already. The user can execute each of these tasks on its own, and they can correct the model's output after each step. And these corrections are on the record. First, we have the document analysis. Document analysis, where a given page is searched for staves. Then for each symbol the model can detect is then transcribed staff per staff. This transcription is agnostic, of course, only the symbols are interpreted. The model makes no attempts to interpret the meaning of the symbols, but just to recognize their shape and their position. And finally, this agnostic transcription is interpreted semantically, and MEI output can then be generated. So how does our training workflow look like? In order to create a training data set for MuRET, we selected 20 representative part books and 1 choir book dating from between 1500 and 1700, which add up to 5,136 pages. We went through 3 training phases for this entire corpus. First, we correct the first page of each of our training pieces, then the first 20 pages of each source, and finally 10% of the remaining pages of each source. And these 10% are distributed equally over the entire document. That adds up to 893 pages of manually corrected notation. We are currently in the 3rd iteration of this training, which means that we are currently working with a model that has been improved twice already, with a total of 400 manually corrected pages from our corpus, but also much more training data from other projects that contribute to the MuRET OMR models. Take a look at the following examples. We have here, as the state at the beginning of last year, there are some relatively grave errors, such as the missing key signatures, as well as less severe ones, such as a minim being read as a semi-minim. Keep in mind here that we conduct our search only based on intervals, not rhythm. Nonetheless, of course, being as accurate as possible in terms of rhythm is, of course, a goal here too. You will notice, though, that if a shape is properly recognized, its vertical position is usually pretty good. Compare this to a current example. This is a pretty common scenario we encounter by now. The vast majority of the notes are recognized properly, with some exceptions, such as the missing dot here. Of course, since our training data is limited and it covers a pretty heterogeneous set of prints, certain less frequently encountered shapes can be difficult to process. For example, our smallest print of merely 52 pages offers an abundance of semi-fusee, and in a typeface that is rarely seen anywhere else, which drives the error rate up very significantly. As for our next steps, first we'll need to extend the amount of symbols MuRET can process. This includes certain meter signs, but also ligatures, or certain ligatures. The latter in particular are critical for our use case, as they feature very prominently in the earlier sources, and their correct passing is essential for melody recognition. So far, MuRET does quite well with recta ligatures, and oblique ligature processing shall soon follow. Another question where we are working on a solution together is how to deal with layout recognition. This is, of course, a very tricky subject, as has been discussed, that requires a pretty sophisticated understanding of implied and context-dependent conventions that can trip up even human editors. The problem encompasses both the distinction between different voices and between individual pieces. For voices, we have to differentiate between part and choir books. In the case of the former, information about the voices can be supplied by the metadata, while the latter, we might have to rely on recognizing the claps to establish at least a hierarchy of voices. As for detecting pieces, we have not yet found a fully satisfactory solution here. Yet. The available metadata is usually not detailed enough to extract this kind of information. It is not inherent in the musical information, and even the textual hints on the page can be misleading or ambiguous. So far, the least error-prone solution appears to simply direct the user to the relevant page where the match was found and leave the interpretation of this extra musical information to them. Once we have figured out ways to handle these pending recognition challenges, we will have to batch process our corpus and integrate it into our existing score search application. The recognition will be handled by the University of Alicante, and our IT team at the Bavarian State Library will process the resulting MEI files to incorporate the new n-grams into our existing index. So that's it for now. Thank you very much for your attention and for giving us the opportunity to share our workflow and experiences in this workshop.
Thank you very much. Wonderful. So, are there questions? I have one question maybe from my side. You said that you're kind of starting with a small batch of annotated data and then doing rounds and adding more. What kind of performance improvements are you seeing for each iteration? Is it that you're already kind of hitting the kind of 100%, or do you actually see for each iteration a large improvement in the performance of the system?
Well, I should preface this by saying that I joined the team mid process, so I haven't seen the very earliest performances, but I have been told that especially things that we now basically take for granted, like the layout recognition, which as for the hundreds of pages I have corrected, worked flawlessly basically every time, was very hit and miss during the first round of corrections. And then in my experience, depending on like what I have seen, it really depends a lot on the kind of print that is at hand. So there are certain prints that just pose an abundance of difficulties. I mentioned the semi-fusee, certain type, like just graphic elements that whereas others are very middle of the road, and they really have evened out to a very high level, as I've demonstrated. Yeah, that makes it difficult to give a gut.
Yeah.
Middle of the third amount of in the third round of evaluations, we can't yet point to like a finished evaluation set, but we hope to. We are keeping score of all the errors we encounter, and we hope to like formally evaluate those once we are finished with this process.
Wonderful, because I think this is also one of the things that might be underestimated, the amount of manual corrections that have to be put in contrast to kind of how much effort you spend annotating and providing more data to understand, okay, where is kind of the sweet spot of how much you have to feed in to make this good enough to make the effort for correcting lower than the effort for annotating. So
Yeah,
yeah,
absolutely.
I think that's definitely an interesting thing to see.